Hello friends, myself Animesh Sharkar. Welcome to our channel Electrical and Automation. Today we discuss about variable frequency drive. What is VFD, VFD components, how VFD works and application. VFD, it is an electronic device to control the speed and torque of an electric motor by varying the frequency and the voltage of the power supplied to the motor. VFDs are commonly used in various applications. Many company manufacture VFD like Siemens, ABB, Yaskawa, Compton Reeves and Schneider. VFD components. A VFD typically consists of a several key of components that work together to control the speed and torque of an electric motor. We discussed about converter or rectifier. Converts the incoming AC power to DC. This is usually done using diodes. DC bus. Smooth out of the DC voltage from the rectifier. It often includes capacitor to filter and stabilize the DC voltage. Inverter converts the DC voltage back into AC with a variable frequency and voltage. This is achieved using transistors such as IGBT. Control units. The brain of VFD, it manages the operation of rectifier and inverter based on input from sensors and use settings. It includes microcontroller or microprocessor and software to control motor speed and acceleration and deceleration. How VFD works. We will discuss on VFD working. Before we have to know about diode and IGBT workings. Diode it is a semiconductor device that allows current to flow in one direction only. A diode is typically made of semiconductor material like silicon. It has terminal, the anode, basically it is positive side, and the cathode, it is a negative side. The junction where this two terminal match is called a PN junction. The electric current passes through the diode in the direction of the arrow diode picture. There will only be electrical current if the voltage at the anode is greater than the cathode. IGBTs. It is an insulated gate bipolar transistor. This type of a transistor used in power electronics for switching and amplifying electronic signal. It is solid state device, which means it has no moving parts. Let's look closely at a typical IGBT gate. This is the control terminal similar to the gate in the field effect transistor. It is insulated from a resistance of the transistor by the layer of oxide. Emitter. This is the terminal through which currents enter the device. Collector. This is the terminal through the which current exits the device. When the gate voltage is low and the IGBT is in it off state, there is no conductive path between the collector and the emitter. And when switching positive voltage is applied at the gate, an electric field is created that allows current to flow from the collector to emitter. 6-pulse rectifier or converter. This is called a 6-phase rectifier or converter. It is where the 3-phase alternating current gets converted into direct current by use of diodes. When phase A is greater than phase B or C voltage, this diode is opens, allowing current to flow. When B becomes greater than phase A, that it is B diode, the opens while phase A diode is closed. The same is true of C phase, as well as for the 3 diodes on the negative side of the bus that result in 6 pulses of current as each diode open and close. The resultant waveform look like this. DC filter. The pulsed DC output from the rectifier stage is not smooth and has significant ripple to create a more stable voltage. Capacitor are used filtering stage. The capacitor smooth out the ripple, resulting in a more constant DC voltage. Inverter section. Now that we have already discussed in IGBT, and we that have an understanding of how our IGBT works, let's back to the application of IGBTs in VFD. The top IGBTs, which in our representing our switches, are in positive DC bus. The lowers are in the negative DC bus. So when one of the top switches is closed, the motor phase and voltage become positive. On the other hand, when one of the lower switch is closed, the motor phase and voltage become negative. Therefore, by controlling the speed and sequence that those switches open and close, we can control the phase and frequency of our signal 0, negative and positive. It is important to note that VFD output signal is a pulse width modulation signal, which turns out to be a rectangular waveform, as it is a variable voltage and frequency that will enable with VFD to control the motor speed. Now we discuss about VFD application. HVAC system. VFD controls the speed of fans and pumps in heating, ventilation and air conditioning system. By adjusting the motor speed, they can optimize energy consumption and maintain consistent environmental condition. Water and wastewater treatment. VFDs are used to control pumps in water treatment plants, sewage facilities, allowing for variable flow rate and energy saving. Industrial automation. In manufacturing and the processing in industrials, VFD controls conveyors, mixer and other machinery, enabling precise speed control and improving process efficiency. Fans. For large scale ventilation systems or exhaust fan, VFD help control airflow rates and adapt to changing demands. Crane and hoist application. In lifting equipment, VFD is enabled to smooth acceleration and deceleration, enhancing safety and control. Agriculture's application. VFD control irrigation pumps, fan in greenhouse and other agriculture machinery, optimization, performance and energy use. Thanks for watching my videos. Please like, share and comments.